Since we don't have broadcast addressing with IPv6, we're going to rely heavily on multicast addressing. So multicast addressing is going to have to now have various scopes identified for it. And what do we mean by scopes? Well, we have to be able to identify how far that particular multicast packet is going to travel, right? We don't want a multicast packet to be routed if it doesn't need to be routed. For example, if I want to talk to just those devices in my local area network, well, then I want to make sure the scope of that particular multicast packet is just reserved for my local link. That's right, my local link. What if it's for my site, meaning we would want to route it, or for my organization, so we'd want to route it? Well, then we'd have different scopes for that as well. And then what about global? If this has to be routable on the internet, then the scope has to be defined as global. So we have different values in the addressing that are going to identify how far the multicast packet can travel. In addition to that, is this multicast packet permanent? Or is it temporary? So all of that is defined in the addressing. So based on that, we will always have multicast packets that are going to be destined to the FF address. So it starts off as FF. So the first 8 bits are always all ones. And then after that, the next 4 bits are going to define the lifetime of this particular multicast packet. So is it a permanent multicast packet or a permanent address here, or is it just a temporary one? Because based on that, we could have different services and features respond in various ways. And then right here, we can see that the scope is listed right here. So the scope can be a value from 0 all the way up to F. Why? Because, well, we are dealing with 4 bits. So 4 bits of all 0 equals 0, 4 bits of all 1s equals F, but you can see the scope definitions here are 1, 2, 5, 8, and E. So depending on the type of multicast packet will determine what the first 4 characters are going to be. For example, if we are setting up a dynamic routing protocol, our dynamic routing protocol is going to be sending out hello packets. So let's focus on EIGRP as an example for IPv6. So EIGRP for IPv6 sends out multicast packets that are hello packets to form neighbor adjacencies. Well, in that case, the multicast packet is destined to who? FF. It's a 0 because it's a permanent address that's reserved for EIGRP multicast communication. And in the scope here, well, I'm forming a neighborship with a device that's connected to the same local area network I'm connected to. So the scope would be 2. So whenever we're dealing with hello packets for our dynamic routing protocols, they are being sent to FF02, meaning these are permanent multicast packets that have a scope of remaining in the local area network, essentially saying they're not going to be routed by a router to be sent to other local area networks. Whereas if I wanted to send something to the internet, then we'd see FF0E as an example, or FF1E. So E, the 4th hexadecimal character, would refer to the fact that it's global. So you're never going to be able to memorize every single multicast packet and the addressing options that are available. So you'll definitely at some point in time have to look up the addressing, and there's nothing wrong with that. But if you remember the scope and how it works, when you see the multicast address, you're going to be able to determine, okay, so this is designed only for the link, or this is designed for a site or organization, or this is designed for global communication on the internet. And they all start with FF. So having a basic understanding of the beginning of the multicast packet will definitely help you long term.